Hello students, today we will take another important topic in class 12th physics, that is potentiometer. It is a device which is used to measure EMF of the cell. Number second, it is used to compare EMFs of two cells. Number third, it is used to measure internal resistance of the cell, which is offered by the electrolyte in the flow of ions. Number fourth, it is used to measure small resistances which are unknown resistances. Firstly, we will study what is this device. It consists of a long wire fixed on a wooden board. Each wire is of 1 meter length and these wires are connected by thick copper strip. Copper strips are working as connecting wires, and these connecting wires are taken as thick to reduce their resistance. Copper is good conductor of electricity, and by making it thick, its resistance will be reduced substantially. These two ends of the potentiometer are connected to an auxiliary circuit. Auxiliary circuit consists of a battery which is connected to an ammeter, which is connected to a rheostat, which is connected to key, and key is connected to other end of the potentiometer wire. And to measure the length of this potentiometer wire, a wooden scale is also fixed along with this potentiometer on the wooden board. From this positive end of this potentiometer, which is connected to positive terminal of this battery, we will connect this system. This system will vary for different purposes: to measure EMF, to compare EMFs, or to measure internal resistance. As per the requirement, this system will vary. This will be connected to a galvanometer, and this galvanometer will be connected to a jockey, and this jockey can be contacted at any point along the length of this potentiometer wire. It is not to be dragged along the length of this wire, because on dragging, what will happen? Its area of cross section may change, or its temperature may increase. So whenever we will contact this jockey with the wire, that contact will be without dragging or sliding it along the length of the wire. Now question is, what is this material made up of? This potentiometer wire, of which material it is made up? It is either made up of manganese or constantan. It cannot be that of copper. Copper is connected, of course, to connect these potentiometer wires, but this copper cannot be the part of this potentiometer, the length of potentiometer wire. This is only connecting wire, you can say. Why magnin or constant is taken? Number first point is its specific resistance is 49 into 10 to the power minus 8 ohm meter, and that of constant is 48.2 into 10 to the power minus 8 ohm meter. Whereas that of copper, the specific resistance is 1.68 into 10 to the power minus 8 ohm meter. This is the case of copper, which is not taken. This we don't take for potentiometer wire. Why? Its specific resistance is too low. And second thing, the temperature coefficient of resistance of magnin and constant is very low. But in case of copper, the temperature coefficient of resistance is very high. What is this temperature coefficient of resistance? Let us see it. Suppose resistance offered by a material at 0 degree Celsius is R0, and the same material when brought up to T temperature, T degree Celsius, its resistance becomes RT. Then these two resistances at 0 degree Celsius and at T degree Celsius are related by this relation. RT is equal to R0 times 1 plus alpha T. From here we can calculate alpha is equal to RT minus R0 by R0 into T. This is called temperature coefficient of resistance. For alloys it is low, for metals and good conductors it is very high. So what we want? We want constant resistance. Means the resistance should not vary with variation in temperature. That type of material is taken, and that type of material is either magnin or constant. On what principle it is based? What is the principle behind this potentiometer? There are two conditions again. Number first, current should be steady. Current is steady. Number second, wire is to be taken of uniform area of cross section. Uniform area of cross section. A is uniform and current is steady. In that case, potential drop across any length of potentiometer wire is directly proportional to its length. This is length of the potentiometer wire. Potential drop, if started from here, is directly proportional to its length. If greater is the length, greater will be the potential drop. Smaller is the length, smaller is the potential drop. What is the condition? Current from here should be steady. Means for a particular measurement, for a particular reading, we need not to vary the current. That is ensured by making the fixed value of resistance, by offering fixed resistance from this rheostat. And second, this wire is to be taken of uniform area of cross section along its length. These are two conditions. So V is directly proportional to L, or V is equal to K into L, where K is equal to V by L is called potential gradient. Potential gradient. What is potential gradient? That is variation in potential along the length of the wire. Per unit length, how much is the variation in potential? The unit length of the wire measures how much potential. That measurement is called potential gradient. It is volt per meter. It's a unitage. And this V, as we know from our previous knowledge, that V is equal to I into R. I is that current which we are saying it must be steady. R is the resistance offered by that potentiometer wire. And on what factors this R depends? R depends. R is directly proportional to length of the wire, and R is inversely proportional to area of cross section of the potentiometer wire. Combining these two, this gives us a relation R is equal to rho times L over A, where rho is called specific resistance. What is this specific resistance? Means resistance of a wire of unit length and unit area of cross section is constant. It varies only with temperature. That or is resistance of unit length of the wire and having unit area of cross section is called as a specific resistance. It is the property of the material. It does not depend on L or A. So R can be replaced by rho L by A in this relation. So we get V is equal to I rho L over A. This V is written as KL. So we can replace V by KL is equal to I times rho L over A. What do we get from here? From here we get K is equal to I rho by A. What is this? This is potential gradient. What does it show? It shows that the potentiometer will be sensitive when K is having small value. For a small value of K, potentiometer will be sensitive. How can we ensure small value of K? K will be small when I is low, when I is less. And K will be small, from this relation you say, when L will be longer. Longer will be the length of the wire, potentiometer wire, greater will be its sensitivity. So how can we increase the sensitivity of the potentiometer? We can increase the sensitivity of the potentiometer by increasing the length of the potentiometer wire. And second thing, we can increase its sensitivity by decreasing the amount of current flowing through this circuit from the auxiliary circuit from this battery. By these two factors, we can increase its sensitivity. So this is potentiometer. It's a principle. What is principle? V is directly proportional to L, provided I is constant and the area of cross section is uniform. And what are its uses? It is used to measure EMF of the cell. It is used to compare EMF of two cells. It is used to measure internal resistance of the cell, and it is used to measure unknown resistances. So one by one we will deal with all its applications. Firstly, we will take the case of potentiometer when it measures EMF of the cell. So we will take schematic diagram of potentiometer. Every time we will not draw the actual diagram of potentiometer. We will take a schematic diagram of the potentiometer. Its application is to measure EMF, electromotive force of the cell. This is our potentiometer wire. This is its A end, this is its B end. It is connected to positive terminal of the battery. This is connected to ammeter. This is connected to rheostat. This is connected to key. And this is connected to other end of this potentiometer wire. That wooden board is replaced by this wire AB. If length of the potential wire is increased, its sensitivity is increased. So 10 meter long potentiometer is always preferred over 4 meter long potentiometer. Now, how to measure EMF of the cell? We will connect it with the cell whose EMF is to be measured. This will be connected with a galvanometer, and this will be connected with a jockey. Jockey can be moved along the length of this potentiometer wire. This is the circuit for measuring EMF of this cell. What we will do? We can connect this key. By connecting this key, certain amount of current will pass through it. If certain amount of current will pass through it, we will touch this jockey at different points along the length of this potentiometer wire, starting from here. From here to here, potential drop is there as per the applied potential. So as per its EMF, we will get a balancing point. At balancing point, this galvanometer will show zero deflection. What does it mean? It means that the EMF of this cell is equal to potential drop across the length L of the potentiometer wire. Suppose at this point we get balancing point. So this, as we know, as per principle of potentiometer, V is directly proportional to L. So V is equal to KL. So what is KL? It's potential drop across the length L of this potentiometer wire, and is equal to EMF of the cell, this cell. It is equal to EMF of this cell, which is to be measured. So E is equal to KL. Now we know that voltmeter is also used to measure EMF of the cell. We have seen voltmeter is used to measure EMF of the cell. But does it actually measures EMF? Does it actually measure EMF? No, it actually does not measure EMF. It measures terminal potential difference of the cell. What is terminal potential difference? Means potential difference across the ends of this cell. For measuring the potential difference, this voltmeter will take current from this cell only. So there will be potential drop across the electrolyte ions inside this cell, because current is passing through it also. So I into R factor is not being measured by this voltmeter. What is this potentiometer measuring? It is measuring E. What is this voltmeter measuring? It is measuring V. What is the difference between E and V? E is equal to V plus I into small r. The potential drop across this internal resistance is not being measured by this voltmeter. It is measuring this V. So this is the difference. Had it been a voltmeter of infinite resistance, it would have measured. So this potentiometer, in other words, is acting as an ideal voltmeter. What is ideal voltmeter? Ideal voltmeter is that voltmeter whose resistance is equal to infinite. So it is offering infinite resistance in the path of flow of current. That's why from this cell no current is being drawn, no current is being taken, because this is showing zero deflection. So this is how we can measure EMF of a cell. Other applications we will study in next class. Thank you.